I'm going up against Maddie. Yeah.
Hey, everyone's attention back this way.
No, the class.
Maddie, don't be a secret agent. Take that out. Thank you.
No, because she's an agent.
Angel, right here. Okay. Dustin, don't be a secret agent. Take them out. Good. Hey guys, teachers usually won't make big deals about that type of stuff if you just remember to take them out. All right? And don't let them be a distraction. Otherwise, then they become big deals. Hey, once again, this is what you're working on right now. You're trying to get this graph and this table taken care of as quickly as you can. Remember, for those of you having a hard time starting, just our quick review of yesterday, that's why we're doing this graph. Those of you having a hard time starting, our y-intercept is when x equals what? 0. So that tells us what goes here. We start out with 0 there. And then our rule, what's our rule here?
1/5 times 5x.
Good, 1/5 times 5x. Okay, 5 to the power of x. Good. That's our rule. The rule goes here, input here, and output here. Okay? So we plug in a number, throw it through our rule, and get an output. All right? This one we should know. Anything to the 0, this part becomes 1. And then 1/5 times 1 is 1/5. Okay?
That's what we're saying. Sorry.
All right, continue to fill out your table. All right, we had some cat-like speed there. Some of you are really fast at getting that table filled out. So what I'm going to do is I'm going to call on each individual, and we're going to get these numbers filled in. I'm just using the random number table on my calculator. It's a cool option. Person number 6. Tyler, what did you get for right here? 1. And so you plug that in, 1/5 times 5 to the first. That's the only thing that changes. This part becomes 5. So what did you get as your output? Huh? 1, yeah. 1/5 times 5 is 1. All right. And number 24, Rachel, what'd you get here? You didn't get it? What should I put here? 2? Okay, so walk me through it here. 1/5 times 5 to the, what goes here? Second. And so 5 squared is? 25. What's 1/5 of 25? Or 25 divided by 5? That's 5. Good. All right. Thank you. And we don't have 28. Number 7. Grace, what'd you get here? 3. And what'd you get here? 25. Okay. And number 11, Angel, what'd you get here?
-1.
-1. And what'd you get as your output?
0.05.
Yeah. 0.04?
Yeah.
Okay. Thank you.
No, 0.
No, 0.4.
Like 0.04.
Oh, 0.4.
Yeah.
All right. Thank you. Unbelievable.
Or 1.
So tough to teach. All right, Kevin, what'd you get here? -2. What'd you get as your output? 1 over 125. Anyone got that in decimal form? 0.008. Thank you. All right. Hey, we're getting like really small now, right? -3. This is like something small. We're going to put small. 0.0016. Okay. All right. So it's really small. We're not going to be able to see that on our graph, right? Okay. If we're going up to 25, what should we go up by on our y-axis? Here, I'm going to let one person pick. We'll say person number 4. Carson, what are we going up by? We're going to go up by 1? Can we fit all these, you think? No, so what should we go up by? Go up by 5? Okay, we'll go up by 5. So 5, 10, 15, 20. All the way 10, this would be? 50. Okay, so now I've defined my scale, 0 to 50. Okay? So -3, it's like right there. I mean, it's hugging the x-axis. -1, really close to the x-axis. 0 is actually extremely close to the x-axis also. It's 1/5. 1 is at 1. Okay, well, if we're going up by 5s, 1 is like
Kind of close.
Yeah, I mean, it's pretty close. 2 is actually at 5, all right. And then 3, we're up at 25. 5, 10, 15, 20, 25. So we probably could have went up by 3s maybe even, right?
Yeah.
That's all right. You're going to say that?
Yeah.
That's what I was going to say.
If you called on me, I was still gonna be like, oh, we're gonna go up by 3.
I used the random number table on my calculator. It was totally random. Okay, there we go. Good. How many got that? Okay, that is an exponential growth function. That's what we're studying today. Now, before we go any further here, we're going to introduce graphing calculators. So how many of you have a graphing calculator? Who does not have a graphing calculator? If you do not have a graphing calculator, you come see me to borrow one. Here we go. We're not going to spend a lot of time on the graphing calculator, but this is our quick introduction. Okay, so looking at our equation, first thing you need to kind of get. How's your hand up already? You push the on button. Oh, who cares? They're just batteries.
How's your hand up already?
All right. Hey, push on. If it does say batteries low though, it'll give you that message for forever. When you know they're really low, you don't see anything anymore. Then you know they're like dead. Okay? So, here's what we're going to do. We're going to go second, mem.
Wait, second what?
Second plus. We're going to reset our memory. So second plus, we're going to go 7, 1, 2. It should say RAM cleared. Hit enter and done. Now,
Where's the
done button?
done, it says done, so we just hit enter.
Oh.
Okay. Now, unless your hand goes up, pay close attention here. Unless your hand goes up, I'm moving on. If your hand does not go up, that means you are with me, and do not wait 2 steps ahead of us to go, oh, I got lost like back there, because I'm going to say tough. You're stuck then. All right? So, if you did not get to here, you need to raise your hand right now. Yes? Second. So we'll go second plus 7, 1, 2. Okay? All right. Yeah. Hey, if you guys have a note page in front of you where you're going to keep just graphing calculator notes, that would be a good thing to write down. But that's really not our big purpose today, so I'll probably go faster. But we'll use graphing calculators more as the year progresses.
7, 1.
Yeah. Second. So the keystroke to get to everything cleared. Second plus 7, 1, 2.
Okay.
The second is. That gets us to the memory when we hit plus. 7 says reset. 1 is all RAM. 2 is
Reset.
confirm. And then if you hit enter, you're back to your home screen. Okay? All right. Now, for those of you who've used these before and you've graphed with them, this is very helpful. These 5 buttons up here, this top row, those are your graphing buttons. Okay, we're going to go to y equals. Why? Because our equation says y equals. It's the only place we put in graphs here. And we're going to put in that equation. We're going to put in 1/5. The way we put in a fraction is we use a division sign because this sign right here in the 1/5 means divided by. Yeah. 1 divided by 5. Times 5 to the x power. Now, some of you have a TI-84. Some of you have a TI-83. TI means Texas Instrument. 83 or 84. This is an 83 that I have in front of me. Those of you who have 84s, this is going to look different when you put this next step in. Those of you who have 83s, you have to really pay close attention here. If you are going to buy a calculator, which if you don't have one of these graphing calculators, if your family has the means to buy one for you, it will be a very, very, very good investment for you, especially as we approach the end of course exam. Buy a TI-84, don't buy a TI-83. Okay? So, what you're going to do is you're going to push the caret symbol. That's this, the up arrow. You push it. Okay? And now you're going to put the 5th power. Now, those of you who have an 84, it actually put a little box up here where the power would go. Yeah. Those of you who have an 83, it doesn't put that. It just expects you to know what programming looks like. Okay? So we're going to put the X. X that we're using, there are a lot of X's on this keypad. the x you always use for x, for the variable x, is right here. It's under mode. It says xt theta n. We're using that. The theta looks like a little 0 with a slash through it. Everyone have it?
Yes.
You gotta raise your hand.
So did you get the x?
Yeah, I got it.
Okay. Okay, graph. And we should get a picture that looks very similar to one we had. Hey, now it looks different because look at our graph. And like I said, I don't want to spend tons of time on this, but looking at our graph and looking at this graph here, the one on the calculator and ours, this one starts at -5 and goes to 5 on the x-axis. Well, our x-axis, the standard viewing window, this is our window into our calculator. Okay? And our standard viewing window goes from -10 to 10. So what we want to do is we want to adjust our window. Remember I said there are 5 keys at the top here that deal with graphing. Some of you are already tuned out. You like doing, maybe you're playing block guy or whatever. Block man, I guess it's called, not block guy. Okay? Maybe it is block man. Block guy. I don't know. But this one right here, which one will control our viewing window? Window. So we push window. It's the one that says window. Okay? And now we want our minimum x value. This is our x-axis. What's the smallest value we have on it? -5. Right here. So we're going to push negative. Negative is down here by the decimal. Okay, it's not the minus. It's this sign. You have to use this. If you use minus, it gives you an error. So those of you who have friends that don't pay attention in class, they will make that mistake here in a minute. You'll have to help them. Okay? And push negative and 5.
Is that on X min?
On the x min. So what's the maximum x value?
5.
Yes. 5. Very good. So we go down, we push 5 for max. What are we going up by on x? 1. That's what scale is. That's already good. The minimum on y. So I'm going to actually go down to here. What were we going up by on y? 5. What's the minimum? What's this point down here? -10, right? And so we're already good there. What's the maximum? 50. What are we going up by? Not 1. 5. So now if you have that, let me see if I can make that any brighter. Okay, if you have that, those settings in your calculator and hit graph, it should look more like this picture.
Yeah, looks just like it.
Okay? Now, usually the graphing's not the tough part, the table's the tough part. How could you get table up here?
Second table or second graph.
Second graph, it says table. And notice there's our table. You can scroll up, you can scroll down, you can scroll all around. Oh, sorry. Sorry, you can scroll. Okay. There we go. But hey, there's our table, right? Right there we have our exact table that we have here.
We're smart.
Yeah, it doesn't say small, but it says. Okay. Good?
Small.
Hey, you guys, the reason I don't show the graphing calculators until about this time of the year is because I really need you to learn how to build a table. It's a great tool, though, if you understand how the math works. And now we're to our last graphing pattern. I start introducing the calculators to you. Okay, if you don't have one and your parents can buy you one, ask them. Seriously, ask them. Okay, TI-84 is what you want to buy because you can upgrade it. And the math print, who has an 84 right here? Okay, can I use that one? The difference between the 84 and the 83, when you look at the y equals menu and you put in, notice these are the same equations here and here. This one says to the power of x. That one actually shows the power of x. When we hit quit, I mean the keystrokes are the same, but if I'm doing like the square root of, I don't know, 1500, that's the square root on this one. On this one, it still does the square root, but it doesn't put it in math print. You have to insert parentheses. Okay, and sometimes I've had students leave that parenthesis off. Maybe the problem is square root of 1500 plus, or maybe times 6. Let's go plus 5. Well, that's the answer. Well, I've had students leave that parenthesis off and go plus 5. That's the wrong answer because they didn't close that parenthesis. Okay? You've got to close it. Okay, so if you can get the 84, you can continually upgrade the operating system. This one you can't. They're almost the same. It's not a big change in cost. Yeah?
I have an 85 and I don't think he has a table.
What's that?
I have a TI 85. I can't find a table though.
You can't find that. Yeah, 83 and 84, the 85, the 87s, the 89s, 81s, some of those don't have the same functions, so it might not have it. 83 or 84 is really what you want. It might have it, but these are the ones you really want.
Is that the one we're using in high school too?
The 84 will be what you use in high school and probably throughout college. This will become one of your friends. Yeah. Yeah. And those of you are like, I just use my phone, man. Like, I got a phone.
No, that doesn't work.
I just use my phone. Yeah, you can't use those on tests. Man. Okay? All right. Hey, sorry, we are done being distracted with calculators. Set those aside. We're going to move on to today's warm-up.
Yeah, that was it.
Yeah, we're going to actually spend 2 days on 8-2 because we'll need it. I was going to spend only 1 day, but we're going to go 2. You need a textbook?
How do you
Open
clear
it to
all?
page 367 and do the work together with the groupies.
Button right here.
Okay, can I get your attention back up here, please? Hey, I realize when I have you do these work togethers, they're not always easy, and sometimes we get frustrated with them, but that's just the way it goes. And it's meant for you to start messing around with this stuff and understanding where you're going to have some of the pitfalls. Number 1, Eddie, will you read that?
Says, how do you find the new wage after each raise for job A?
So for job A, how do you find the new wage for each rate for job A? Can I borrow your book there? Thanks. Okay, so if this is my graph, it says suppose you offer a choice of 2 jobs. Job A is starting wage at $5 an hour with a 50% or a 50-cent raise every 6 months. Job B starts at $4.80 with a 10% raise every 6 months. How do you find the new wage for job A? So if I say, hey, you start out at $5, after 6 months, what's going to happen? Yeah, you're adding 50 cents, so you're now at $5.50. And then after a year, you're at $6. So we're adding 50 cents every time. Number 2, in job B, each new wage is 110% of your previous wage. How do you find the new wage for job B?
Multiply by 10%.
Okay, yeah, we're increasing 10%. Now, here's the deal. Here's where some of us may struggle a bit. We get job A. We start at $5. This is now what? $5.50. Here is 6. Here. Okay, and so on, right? We keep going. Tell me if I make a mistake, please. All right. And then job B, we start at $4.80. Is that right?
Yes.
Okay, we start at $4.80, and now we're increasing 10%. Okay, don't text your friends about it. All right, just make sure that you're paying attention on it. Okay? Hey, everyone knows right where to look. That's not good. Okay, I'm just saying. All right, so if we're at $4.80 and we're increasing 10%, what I've told some of you, that's like thinking percents. When you're dealing with percents are like thinking in terms of coins. How many ever have change in your pocket anymore? Like not bills, like coins, pennies, nickels, dimes. Okay, in your wallet, in your pocket, wherever. Okay, if I'm dealing with 10%, that in decimal form is the same thing as 10 cents. Okay, if I'm talking about 1%, that in decimal form is the same thing as 1 cent. Everyone know the difference between 10 cents and 1 cent?
Yes.
Yeah. 1 cent, how do we write 1 cent?
0.01.
Good. 1% then is 0.01. 10%, how do we write 10 cents?
0.1.
0.1, and some people put the 0 at the end. That's 10 cents. That's 10%. What's 100%?
0.01.
Good. Yeah, 100% is like 1. It's like $1, right? It would be 100 pennies. Okay? It'd be $1. So we write it as 1. We change in those 100 pennies for 1. Everyone see that? That's when our coins become a bill. Right? Everyone understands that? I'm hoping that that makes percents a little easier. Percents are just like coins in your pocket.
So like,
Okay, so like here, when we're saying we're increasing a 10% every time, it means so Eddie, if you have this job, if Eduardo has this job, and he initially got $4.80 an hour. If he goes on to the next hour, he's now getting, well, does he still get $4.80?
Yeah.
Well, at least
yeah.
he still gets that much, right? They're not going to say, hey, we're going to give you 10% more, but we're not going to give you the original $4.80. So you just get 10% of $4.80.
that's stupid.
10% of $4.80, he gets the $4.80 plus a little more, right? He doesn't want the little more without the $4.80. Otherwise, he just gets paid a little. That'd be a bad deal. You'd be like, I don't want to work here anymore. Okay? So what is the little more? It's 10% more. And you're saying that is 48 cents, right? We just moved the decimal over one spot. It's 0.48. That's how much we're adding to it.
And you get 5.2.
5.28. Now, there's an easier way to get that. If you think of this in terms of percents, 480 is what percent of 480? 480 is what percent of $4.80? It's 100%. This is 100%. What percent of $4.80 is 48 cents? That's 10%. What's 100% and 10%? That is 110 whopping percent. And 110%, what is that in terms of?
$1.10.
Yeah, it's $1.10, right? It's 1.10. If we're thinking money terms again. Everyone with me? So I want everyone to take 4.80 on their calculators and multiply it by 1.1. If you want the 0, you can. You don't need it. Does that give you 528?
Yes.
Yes.
You
Okay.
do that every time.
You can do that every time. So we multiply by 1.1 here. Now take that 528. If you're still using the graphing calculators, if you just hit the time sign again, it'll say A and S for answer. It's taking this answer, the 528, and you're multiplying that by 1.1. What does that give you?
5.8. 5.81.
5.8.
1.
808 or 8,
Yeah. 808.
81.
That's what I said.
Yeah, that is what you said. All right. And then we multiply that by 1.1 to get
6.39.
39er. Okay.
7.03.
And 7.03. Some of you are fine. Okay.
7.73.
7.03.
No. Yeah, that one is. And then 7.73. And then $8.50.
Okay. Now I'm hoping everyone's seconding this because I'm in pen. I should be in pencil here. $8 and what?
50 cents.
50 cents. We good? Which one was repeated multiplication and which one was repeated addition? Well,
Job B.
this one is adding 0.5 every time. What relationship is that? Is that linear or exponential?
Linear.
That's linear. This is exponential. Tell your neighbor why this is linear and this is exponential.
Because you're adding more to different and multiplying.
41.
Yeah.
That's linear.
Okay, why is job A linear? You're adding. Job B, you're multiplying. Hey, is this arithmetic? Is A arithmetic or geometric?
Arithmetic.
Arithmetic. B is
Geometric.
geometric or arithmetic. I don't know. It's one. All right. Any questions?
No, sir.
Okay. Very good. Moving on. Hey, yesterday you guys copied this down. Today we're talking about exponential growth, but you've already we've talked about y equals abx. A is, tell your neighbor what A is.
Wait, I didn't hear the question. What?
Tell your neighbor what A is. What A means.
Starting amount of your y-intercept.
Good. A is your starting amount. We also call it our initial value.
She's like, how'd you know that? It's right.
Okay? Our initial value. Tell your neighbor what A was in this previous problem.
5.
What was A for job B?
0.
Okay? McKenna, what was A? Or what was A for job B here? 480. Now I'm going to write that here so we have it. Okay? What was B, our base?
50 cents.
It's a little tougher.
48 cents.
Oh, I'm on job B.
48
or A.
cents.
1.10.
Oh, 1.10.
What were we multiplying by every time? 1.10 or 1.1. We could also call that 1.1, right? You don't have to put the 0 at the end.
I always do. I don't know.
Okay? If it makes you feel better, there it is, though.
It does.
All right? Number of increases is x. So what I want you to do now, for the problem we just did, I want you to write the exponential function in standard form for this problem. Okay, on your paper.
Okay.
Once you get it, show it to your neighbor and brag how smart you are.
I always do that.
Did you get
And what am I saying?
wait, what are you doing?
Write the exponential function for job B.
Did it?
What'd you get?
Did it? What is it?
We don't answer it.
Oh. Can't go. 1.8 times 1.1.
Okay, who has it?
4.8.
Oh, who thinks they have it?
1.1.
I think I have it.
Who knows they have it?
I know I got it.
Who thinks they might have it? Who has nothing?
Oh, my hand. Ow!
Okay, what is the general form we're using?
A, B.
Y equals ABX. What are the two variables that we leave?
A and B. Oh, wait. Y and X.
X and Y. That's how we graph it. So we need to replace A and B. Do we know what A and B are?
Yep.
Yeah.
Yes. So Harrison, what'd you get?
Y equals
Wrong.
4.80 if you want.
0 if you want.
And then parentheses 1.1. And then end parentheses. And then to the power of x.
To power up. Can I put the 0 if it makes me feel better?
Yeah.
Okay. Phew. Yeah, you don't have to, but there it is. How many had it? And that's a lot more hands than people who even thought they had it. So like, okay.
Well,
I-
some people just aren't confident.
Some
in
people,
themselves.
that's okay, they should be.
And then
So today we're doing growth. Growth is when B is greater than 1. Growth,
Wait, do you want us to write that down?
yeah, that's probably a good
Oh
idea.
crap! I answered it.
Growth is when B is greater than 1.
Growth is
The graph of an exponential growth function will either look like this, maybe. Actually, I want you to pick which one of these is an exponential growth function. It's one of these two.
someone's that way.
First.
How many think it's the first? How many think it's the second? Who says first? Who says second? Why is it the first?
It's going up.
Yeah?
Roman.
Good, it's going, well, this one's going up.
Ooh.
Well, it's going from negative
Yeah.
to positive.
Yeah, and it starts below 1. Like you get like a decimal point something.
Okay, so this
Yeah.
one starts down here. We read graphs from
Left to right.
left to right. Okay, top to bottom, left to right. So here, it's starting here, and it's going up. Here, if you're reading from left to right, it's actually going down, which is a nice slide, but, you know, okay. This one's like a jump.
Slide. There you go.
All right? So we want this. Exponential growth looks like that one. Alrighty. Hey, why don't you try this problem right here? When you use exponential functions to model real-world situations, you must identify the initial amount A and the growth factor B to show growth B must be greater than 1. Go ahead and answer question 7. You can just write in your notes, page 368, number 7, and just write A, B, C, D, E. Put each part there. See how we did. The initial amount. What's our initial value?
50,000.
50,000. How many got 50,000?
My hands up, I just don't want to.
Well done. Okay. The growth factor B is 100% plus 3%, which is 1 plus 1. 100 is 1. What's 3%?
0.03.
0.03. How many got 0.03 there? Yeah, you were right. Which gives us what here?
What?
1 plus
1.03.
1.03. Hey, if you guys get that part down, this makes it a lot easier because a lot of students put 1.3 there,
That's
which is 100 plus
30%.
30.
Which is not right.
That's not right. That's more money than you have, dude. Okay, you only got 3 cents. All right. To find population after 1 year, you multiply what by 1.03?
50,000.
50,000.
Totally guessed.
Okay, don't guess.
No, I wasn't.
This is to the power of x, which we are making 1 here, right? So that became 1. Okay, complete the equation. Victoria, what'd you get right here? 50,000. Yes. Jordan, what'd you get here? Nothing. No, it's not 0.
Close.
What's our B term? What's our rate of growth? Yeah, we're going 1.03.
You have to put parentheses.
Parentheses a good idea. To the power of, what do you think, Ashley? X, yes. X. 1.03 to the power of x. We'll zoom in there. Okay, so in this last part it says, use your equation to find the population after 25 years. So our equation, y equals 50,000 times 1.03 to the power of x.
I got something crazy.
Okay? Kevin, what are we plugging in there? 25 for what?
I
For x. That's how many times we're repeating this. 50,000 times 1.03 to 25th. Anyone get that? McKenna, what'd you get? Is that it? 9/10 of a person?
0.9.
That's bad.
Oh. we should
So
just say
probably in realistic, we'd have to just call it.
Rounded.
We're rounding, probably round up in that one. 689. Okay. So 104, 689. Oops, 689 people.
Yeah.
Yeah, you don't want any partial person. That's gross. Okay.
It's like getting in the word with hand.
what?
Hey, questions?
Person.
Rate yourselves 1 to 5.
Wait, what?
Okay. Hey, that's a good initial discussion. Now tomorrow we're going to dive into what's called compound interest. Okay? But on the sheet you got on the way in, everyone take a look at your assignment. Here's what I want you to do tonight. Okay? Anything with compound interest. So like when we read, we're only working on the front page today, nothing on the back. Okay? Anything that says compounded, and you have to compound more than once, then we're going to have problems. So like number 2, you're going to have to skip right now.
Just press skip.
No, just put a box there. That's one we're not doing today. Okay? But these ones right here, this one says suppose one of your ancestors invested $500 and $1,700 into an account, 4% compounded annually. That means how many times is it compounded per year? So if you compound something annually, that means you're getting interest annually. How many times is that per year?
12 times. Wait, what?
So like if I put money in the bank today and the bank says, hey, we only compound annually. That means next year at this time we're going to compound your interest. That means we're going to give you your interest. So that would mean on $100 I get 4%. I get $4. On $500 I get $20, right?
Oh yeah.
Because 500 times 4%, it would be $20. So I'd have 520 after 1 year. You're only compounding once when you're compounding annually. So down here on number 2, even though we're not doing this tomorrow, just so you have a note to yourself, annually means X's you're compounding once. What would it mean semi-annually?
Half.
It's half. It would be 2 times a year, every 6 months.
Quarterly is 4.
What's quarterly?
4 times a year.
4. 4 quarters in a dollar. What's monthly?
12.
12. Okay, so we'll deal with that more tomorrow. But on number 1, well, all you have to know is you're using y equals abx. And in this case, you're trying to find the balance, or find the account balance after each of the following dates. The year 1750. How long has your money been in the account then?
50 years.
50 years. Okay, that means X is now changed to 50. The year 1800. That is now 100 years. That means X is now 100, and so on. So you got 4 different problems there. Number 3 you have to do tonight. So do 1, do number 3, and do number 4. Number 3, the starting salary for a new employee is $25,000. The salary for this employee increases 8% per year. This is just the same type of problem we've been doing. Okay? And then number 4, suppose you invest $750 in an account paying that much interest, compounded annually. That's how many times a year? Once per year. Okay, find the account balance after each of the following. All right, so do 1, 3, and 4 tonight. Okay? Here we go.